Woohoo, we're live, and I hope you have your support systems in place because we're about to do completing the square. And completing the square is I'm thinking I don't want to be too broad with this, but I'm thinking it's nobody's favorite part of algebra. It's certainly not my favorite part. It took me a long time to figure out what the heck was going on here. This can be very complicated. These problems can take a long time. And the good news is, though, we're going to do them. I'm going to show you how to do them. It's a really great technique. We're going to use it now, and we're going to use it again in chapter 10, oddly enough. But for the most part, I'm going to go right into 8.2 where we will show you the shortcut. So there is a shortcut for doing this. So don't panic too much if this is a little bit over your head. If you're going into calculus, sit down, pay attention, make sure you understand it because this is something you're going to have to be able to do. Those of you who are just here in math for a little bit, get as much as you can out of this, but don't break your brain. There is a shortcut coming. Woohoo. Okay, so we are in chapter 8 and 8.1, and hopefully you were watching when I was just in my last video talking about the square root method. So what is the square root method? The square root method says we're supposed to start with something squared equals a number. But what we have is x squared plus 6x plus 5 equals 0, and this is not a perfect square. Now, in the past, maybe the correct answer was run away. But hopefully you've caught on that we are no longer running away from things. As algebra starts to gain momentum, we're going to be like just digging in and saying, okay, we're not leaving this table until we figure this out. And so this is when we're going to use the method completing the square. Now let me go walk you through some words. Completing means finishing the square, the perfect square that we're looking for. So this is the method. I'm going to show you my method. There are quite a few other methods, so I would encourage you to look around on the web because completing the square doesn't always have to be the way I'm about to show you. There are a couple other ways to do it, but this is the way that I do it. So let's start off with our equation. So far, so good. Okay. Now, we're going to take this 5, which is not helpful, and we're going to chuck it to the other side. It's not helping us anything at all. So we have our new equation. It looks like this. Now, if you were here for all of the chapter on quadratics, you're like, oh my gosh, you messed up the quadratic. We had a 0. And in fact, some of you might have noticed, wait a minute, you can factor this. Why are you doing this? And the answer is the reason I'm doing it with this one is a nice one. We'll do a nice one, and then we'll do some yucky ones. So we're starting with the nice one. So yes, if you factored this, hint, hint, x plus 5, x plus 1, you'd be done with this problem by now. But I want to show you this other method. Okay. So far, so good? So a perfect square, actually, let me not squish it back that far. Let me remind you, a perfect square, when it has x plus a, the quantity squared, oops, sorry, I'm going to throw my pen. Haha. It equals x squared plus 2ab plus... What? Oh my goodness. Seriously? I can't take me anywhere. Oh. Yeah, you guys know what this is. X plus a, the quantity squared. You could so do this better than I can. To xa plus a squared, right? So in the middle term, I've got an x times 2a. Okay, so this is just a reminder, just a little reminder. So, but what's important here is in the middle term, I have an x, but then whatever's left is 2 times a. So if I have 6 times x, my a is actually 3. So this is what I'm going to do. I chuck this number over to the other side. Just get it out of the way. Then I'm going to take 1/2 of whatever number is here. 1/2 of 6 is 3. Okay, that's fine. And then we're going to take 3 and we're going to square it. And you're going to be like, what? Why would we square it? Well, let's look back over here at the perfect square. I found out what a is. A has got to be 3 in this one because the middle term is 2 times a. So the 1 times a is 3, the number I'm really interested in. But then we got to end the perfect square with the 3 squared. So that's going to be my 9. Okay. And then I'm going to take my x squared plus 6x and I'm going to add my 9. Now, I can't just go adding 9 to equations. I have to add 9 to both sides. That's all. So now I've basically futzed around and I've created, and you can double check me, this is a perfect square. Yay. Now, over on the other side, I got possibly a mess. So honestly, the other side, this takes the hit. My focus is the left. The right-hand side is just like my junk drawer. So I've got x squared plus 6x plus 9. And then over on the right, as it turns out in this case, because remember I told you this was a nice one, I get 4. Okay, that's very pleasant. You know, it's not 17, thankfully. Sometimes it is 17, and no one likes that. Okay, I'm sure there are fans of 17, and I have just offended all of them, which is why I turn off comments, because I don't want to hear about the pro 17 group, because 17 is just wrong. It just is. I'm sorry. It's no one can change my mind about that. 17 shouldn't even be a number. It should be embarrassed. X squared plus 6x plus 9, I claim factors into x plus 3, the quantity squared. So once I've got a perfect square over here, look at that beautiful thing. I square root both sides. Now, let's see if I can get this right this time. You know, 5 times out of 3, I'm generally going to get it wrong. I square root both sides, haha, and I add in a plus or minus. Why? Because when you take square roots, when you take radicals of things, it totally forgets to consider the minus possibility, the negative possibility. So we got to put it in for it. Square roots are very single-minded. They can only see pluses. So I got x plus 3 over here, and I got plus or minus 2. Subtract 3, subtract 3. I get x equals -3 plus or minus 2. X equals -3 plus or minus 2. Okay, lovely, lovely. What does that mean? -3 plus 2 or -3 minus 2, right? Plus or minus 2, so we got to go with both. -3 plus 2 is -1. -3 minus 2 is -5. X equals -1 or -5. And remember, the comma means or, so you don't even have to write the word or. Now, remember when we talked about this to begin with, and I said, wait, you guys are probably seeing that we can factor. Remember how we could factor this? This is x plus 1, x plus 5. Notice the answers we got, -1 and -5. Bam. Woohoo. Okay, that's page 1. And I hear you saying, wait, but that seems fine and nice. Why don't you like completing the square? That seems so sweet and innocent. And I'm like, okay, yeah, let's go with that for right now. Sure, let's do that. Lovely. Okay. Problem number 2. Let's complete the square here. So I've got x squared minus 8x plus 30 equals 0. Pretty much, if this number is not a perfect square, chuck it. Just chuck it. Oops, sorry. -3 minus 30. X squared minus 8x equals -30. I didn't like the way I wrote that. Let me write it again. That's the great thing about having big pieces of paper. You can write anything you want. Want to write it 5 times? Let's write it 5 times. Free country. Maybe. Okay, now, what are the steps? This is the hard part about completing the square. And this is the thing. Everyone's got their different rhythm. So you kind of have to, hopefully you'll do a bunch of these problems in the homework and develop your own rhythm. But this is the way I approach it. Because I know this is 2 times a, I'm going to take this number and I'm going to multiply it by 1/2. And the exciting wrinkle this time is I've got a minus. Then I'm going to take the results of that and square it. That's the number I want to stick in on both sides. X squared minus 8x plus 16, see, I put it in there, equals negative 30 plus 16. And let me see if I can talk this into not smearing. I don't know if I talked it into not smearing, not terribly well. Okay, there we go. I add 16 to both sides. Literally, this is the step. I have completed the square. That's what I'm doing here. And over here is just whatever happens, because what's most important is this one, completing the square. Turns out this is a perfect square if you do this correctly. And I'll give you a little hint. The little hint is that this number always matches this number up here. So you don't even have to do the completing. If you follow my methods, my handy dandy completing the square methods, it's all just going to fall into place. Doesn't mean you're going to like it, just means it's maybe a little bit easier. Okay, I got x minus 4, the quantity squared equals negative 14, which normally people would be like, run away, oh my goodness, what are we going to do? And I'm going to say, you know what, don't sweat it, don't sweat it. Just square root both sides. Don't panic. Or radical both sides for purists. Okay, so far so good. I do not like this. I do not like this, but over here, radical, square, cancel each other out. I get x minus 4. Now I have to deal with this. So we think about what's inside there. First of all, if there's a minus, I've got radical 14i. And now books deal with this differently. This is why I've got this little garage door at the end of my radical to make sure the I doesn't fall inside. If you get an I inside your square root, life gets really, really hard, really fast. Because I can tell you that the square root of I is a complicated question. So let's keep the eyes, keep your eyes on the outside, right? Don't put your eyes on the inside. And then let's think about the square root of 14 or radical 14. 14 equals 7 times 2. There's nothing else in there. There are no twins. No one's getting out of there. The the bear can yell at the door. Rah! But nobody's coming out, nobody's going in. So at least there's that. I'm going to add 4 to both sides. X equals 4 plus or minus radical 14i. And if you are, oops, sorry, that's too low. And if you're asked to write them both out, it's 4 plus radical 14i or 4 minus radical 14i. Whoa. Okay, we're at 13 minutes. I am going to throw, 14 now. Wait, now. Okay, 14 minutes now. I'm going to throw caution to the wind. I'm going to do the last one because they kind of go together, in that Sesame Street kind of, these 3 kids are just like each other. Let's celebrate being lockstep with your friends. Hopefully you are just like each other. Otherwise your friendship ends. Sorry, I'm a little punchy. Okay, that was not true. You should not be just like your friends. Then what's the fun of that? You always agree. Now, I want you to hug your teddy bear tight to you and recognize that we're going to do one more of these. You're going to do some of these in the homework. And then I'm going to give you the shortcut in the very next video. So there will be a shortcut in the very next video, okay? So here's what I'm going to recommend. 3x squared plus 6x minus 1 equals 0. What's the first step without even having to think? If someone says complete the square, let's add 1. Bam. 3x squared plus 6x equals 1. Now, you've probably noticed that something weird is happening, and that is there's a 3 here. While it is possible to do completing the square with the 3 intact, it is ill-advised. I've tried that. I've tried teaching it. It is brutally difficult. So what I'm going to say is, even though we're about to tread in the realm of rationalizing denominators and fractions and all that, we're gonna do it. So divide everybody by 3. Everybody gets divided by 3. Yay. And remember, hold tight to your teddy bear, and remember, very next video is going to be me showing you the shortcut. X squared plus 2x. See, this is very pleasant over here. Equals 1/3 in the junk drawer. Ugh, 1/3. Okay. So now, any thoughts? Well, we're going to take this number and we're going to take half of it. And I am thrilled to tell you that the answer is 1. And then we're going to take the 1 and we're going to square it. And that gives us 1. So far, so good. And then we're going to add 1 to both sides. And over on the right-hand side, on the left-hand side, everybody is happy. This is x plus 1, the quantity squared. I can use my blue pen to point out that this matches that. Life is good. Over on the right-hand side, I really need to come up with the sum. So 1/3 plus 1 is equal to 1/3 plus 3/3, right? 1 is equal to 3/3. So that's equal to 4/3. So over on the right-hand side, I've got 4/3. Okay. Take a deep breath. Remember, there is hope. There is going to be, the sun will appear to come up tomorrow, even though it's really the earth moving. But the sun is in its own fashion moving. You know, the galaxy are expanding. So technically speaking, you may be getting further and further away from completing the square right now, especially if you were on another planet. You'd be getting further and further away from math. You'd also be suffocating, which would suck, but, you know, away from math. So, you know, it's a trade-off. Take the square root of both sides. Aha, you thought I forgot. I did not forget. Over on the left, I've got x plus 1. Over on the right, I've got a whole footlocker full of pain. Radical 4 over radical 3. And I'll remind you that what we have to do, we have to rationalize the denominator. I'm going to multiply top and bottom by radical 3. I know, nobody wants to multiply by radical 3. I know. It's not what anyone wants to do. The good news is, though, if you're studying math, you will eventually get to stop doing this. I will do this for the rest of my life. Sobering words. Plus or minus. Now, up top, I've got radical 4 times radical 3. Down on the bottom, I've got radical 3 times radical 3. And thank goodness, I also have a hefty supply. Wah! Oh my goodness. See what happens? We start doing rationalizing the denominator and the camera falls, and man, this stuff is evil. So this is my next page. I've got x plus 1 equals plus or minus radical 4 times radical 3 all over radical 3 times radical 3. See, same exact thing. So let's move over here. We're almost there. We are almost there. It's seriously, it's well within our sights. I know we're at 19 minutes. Let's see if we can get it done before 20 minutes. I've been told that your brains will smack shut exactly at 20 minutes. So x plus 1 equals plus or minus radical 4 times radical 3 all over radical 9. I know I'm combining the bottom ones, but not the top ones. X plus 1 equals plus or minus radical 4 is 2. And radical 9 is 3. Do you see that? Do I have some colors? Radical 4 is actually the 2. And the radical 9. Ooh, this one is super smeary. I must have bought the extra smeary pack of highlighters. Radical 9 is equal to 3. So x plus 1 equals plus or minus 2 radical 3 over 3. Subtract 1. Subtract 1. X equals negative 1 plus or minus 2 radical 3 all over 3. So x equals negative 1 plus 2 radical 3 over 3, or negative 1. Oops, we're almost there. You can do it. Radical 3 over 3. Bam. So I hear you saying, that was 21 minutes of pure hell. And I'll say, yeah, it actually was. But what's coming up next? The shortcut. And the downside to the shortcut is you have to memorize a really bonkers collection of things. However, the good news is you're already on YouTube. And so what I'm going to recommend is that you go on to YouTube and in a separate window, so you can keep watching my videos, also search for the quadratic formula song. Everybody has sung this thing at one time or another. I've sung it. My singing days are over, but you can sing it too. So I'll see you back here. Woohoo. Math on. You did it. We survived.